Question is, a staircase contains 3 steps, each of 10 centimeter height and 20 centimeter wide. This is 10 centimeter and this is 20 centimeter. It is in centimeter. What should be the minimum velocity with which the ball rollings of the uppermost plane so as to hit directly the lowest plane? Suppose this ball is moving with the speed v. Now we have to calculate with what minimum speed it is moving such that after leaving this first step, this is first, second and third step, this is floor. So after leaving this first step, this ball directly strikes the ground. It is possible when this ball reaches this point. If this ball reaches this point, then again it will fall on horizontal ground somewhat here at some distance x. If we throw with more speed, it will move further away. If we throw with some more speed, it will move like this. If we throw with some less speed, it will move like this. Now if this ball missed the second step, third step, the corner of this third step, then it will fall on horizontal ground. So when the ball is at this distance, watch this video. When we project this ball, it moves on a horizontal ground. It moves like this. First slide and then when we throw this ball, it moves horizontally on the first step and then it again starts falling. If we miss third step, then when it misses the third step, it will fall on ground. So now in this situation, we know acceleration due to gravity is acting vertically downward. So I will write the initial speed, let the initial speed of projection be v0 and uy is 0. So the total horizontal displacement of the particle of this projectile starts its motion from here. It will be from here to here. It is not a projectile because it is moving on a smooth surface. But after this point, it moves freely in air. So it will behave as a projectile. So when it passes this point, the total horizontal displacement is x is. When it passes this point, the total horizontal displacement is 20 plus 20, that is 40 centimeter, or it is equal to 0.4 meter. In the same way, the vertical displacement is, when it is here at that instant, the total vertical displacement of this projectile is only 20 centimeter, that is equal to 0.2 meter. Now acceleration due to gravity is downward and let it be 10. So we can say horizontal displacement is horizontal speed means v0 into t, and vertical displacement is uy. Uy we know 0. Since this vertical displacement is also downward, so I will write here minus 0.2 is y, which is equal to uy means 0 minus 1 by 2. Ay means it is 10 into t square. So from here we get t, that is equal to root over, it is 0.04, which is equal to 0.2 second. So if I substitute the value of t here, I will get 0.4 is equal to v0 into 0.2. So from here we get v0, that is equal to 2 meter per second. So this is the answer. If we throw this particle with more speed, it will fall here. If we throw it with some less speed is less than 2 meter per second, then it will strike the stair. See, a shot is fired at an angle alpha to the horizontal. This angle is alpha. Up an inclined plane whose inclination is beta. This angle is beta. So that the projectile strike the hill horizontally if tan alpha is equal to 2 tan beta. So this question says this projectile strike it horizontally when it is moving horizontally. This is our incline, it strikes it horizontally. Means this height, this is the maximum height h, and this distance is range by 2. The projectile is moving horizontally when it is at its maximum height, and this distance is half to that of the range. So this is r by 2 and this is h. H is the maximum height attained by the particle. This is the particle when it is projected. It strikes the inclined plane horizontally. Now, from here we can say h is equal to v naught square sine square theta. Sine square theta means it is alpha by 2g. This is the maximum height attained by the projectile. Now, we know range by 2. So, r by 2, that is equal to v naught square sine 2 alpha means 2 sine alpha cos alpha divided by 2g. This is the value of r by 2. Now from this triangle, this black triangle, we can say tan beta is equal to h divided by r by 2. So tan beta is h. We know the value of h is v naught square sine square alpha divided by 2g whole divided by r by 2. We know r by 2 is v naught square sine alpha cos alpha divided by g. This 2 will cancel out. So from here we will cancel this v naught square. We will cancel this sine theta, sine alpha. We will cancel this g. So this comes out to be 1 by 2 tan alpha, or tan alpha is equal to 2 times tan beta. This is the relation. Now this question is, two projectiles are thrown simultaneously as shown. At same instant these two projectiles are thrown. Let the time be 0. At t is equal to 0, these two projectiles are projected. What is the value of v for which these two projectiles collide? So for the condition of collision, suppose this particle is moving like this and this is moving like this. So for collision, the horizontal displacement, this is particle 1, this is particle 2. The horizontal displacement of particle 1 is x1, which is equal to v cos 53 degree into t, because ax is 0. In the same way, x2 for the second particle is 70 into t, and we know x1 plus x2 is 200, or v cos 53, we know cos 53 is 3 by 5 into t plus 70 into t, that is equal to 200. This is our first expression. In the same way, when they meet at this point, the vertical displacement of this particle is 150 plus, let it be y, let this distance be y. So it is 150 plus y is equal to v sine 53 means 4 by 5 into t plus 1 by 2, g means 10 into t square. Now we also know the value of y is same for the second particle. So for the second particle we can say y is 1 by 2 into g means 10 into t square. So if they are colliding, the time of impact must be same. The time of flight for the first and second particle is same. So from this first and second expression, if I substitute the value of y here, I get 150 plus y means 5t square is equal to 4vt by 5 plus 5t square. So this 5t square will cancel out. We get 150 is equal to 4v into t by 5. This is our second equation from first and second. We can say 200 by 3v plus 5, 3v by 5 plus 7t. This is the value of time from first expression, which is also equal to 150 divided by 4v by 5. So from these two expression we get v as 150 meter per second. After solving this t, we get t from here and t from here. These two t are same, so we can equate these two t, and solving it we get the value of v. So this is the speed of projection of the first ball. Two inclined OA and OB having an inclination 30 degree and 60 degree with the horizontal respectively intersect each other at O, as shown in this figure. A particle is projected from point P with speed u 10 root 3 meter per second along a direction perpendicular to plane OA. If the particle strikes the other plane OB perpendicularly at Q, calculate the time of flight, the velocity with which the particle strike the plane OB. It is given the particle is projected, this angle is 30 degree, this is 60 degree. The particle is projected with speed u perpendicular to this inclined plane. It strike this point Q perpendicular to this inclined plane OB with some speed v. If u is 10 root 3, now first we have to calculate with what speed, what is v, and what is the time of flight. So before solving this question, we will have a look on this video. These are the two inclined plane. The angle of reflection here is 30 degree, here it is 60 degree. A particle is projected from here perpendicular to this inclined plane. The motion of the particle. See the motion of this particle. It strikes this inclined plane. Now let's come to this question. This particle is projected with speed u, which is 10 root 3. Now we can say the horizontal speed of this particle. We know this angle is 30 degree, so this is 30 and this is 60 degree. This angle is 60 degree, so this is 60 and this is 30. Now we know the horizontal velocity of projection is u cos 60. And at any instant the velocity will remain same along x-axis, so this must be equal to v cos 30. The speed of projection along x-axis is u cos 60 and the velocity with which it strikes the inclined plane OB along x-axis is v cos 30, and these two horizontal component must be same because there is no horizontal acceleration, x is 0. So these two are same. So we know u, it is 10 root 3 meter per second. We know cos 60 is 1 by 2. That is equal to v cos 30 is root over 3 by 2. So these two will cancel out. We get v is equal to 10 meter per second. So this particle strike this inclined plane OB with a speed of 10 meter per second. Now, when the particle is moving, it is upward, uy. Uy of the particle is, for time of flight, we can calculate time of flight by using the relation v is equal to u plus at along y direction, and along y direction. So uy, we know uy is u sine 60 and vy is v sine 30. This is equal to u is 10 root 3, 10 root 3, sine 60 is root over 3 by 2. So it comes out to be 3 in root 3 into 5 is 15 meter per second. And this is equal to v10 into 1 by 2, that is equal to 5 meter per second. So if I substitute the value of vy here is in downward direction. Here uy is in upward direction. This is uy. So I will write vy is minus 5 and uy is 15 plus 15. Ay is again downward, the vertical acceleration g is directed downward, so g is minus 10 into t, and this t is the time of light. So solving it, we get t that is equal to 15 plus 5, that is 20 by 10, that is equal to 2 seconds. So 2 seconds is the time of light of this particle. So this particle take 2 seconds to strike this plane OB. A projectile is aimed at a mark which is in the horizontal plane through the point of projections, falls a centimeter short. See, this distance, if this projectile is projected at an angle alpha, it falls a centimeter short and goes b centimeter too far when it is projected at beta. So that if the velocity of projection is same in all the case, the proper angle of elevation is this. See, if this particle is projected with some speed, let it be v0, at an angle alpha, it falls a distance a before. This distance is a. If it is projected at an angle beta with same speed v0, it moves b distance away. Let this distance, the actual distance is c. This is the point where we have to send this projectile. If the angle of inclination, let the proper angle of inclination be theta. If the speed is v0, then it strikes this point C. In this case, the range of the projectile is C minus A. And we can say C minus A is equal to v0 square sine 2 alpha by G. Here the range is, this distance C is C. The range is C plus B, which is equal to v0 square sine 2 beta divided by G. Here the range is C and this is equal to v0 square sine 2 theta by G. This is our first expression, second expression, and this is our third expression. From first and second, if multiply this, multiply first by B and second by A, we get C minus A is equal to v0 sine 2 alpha, this is v0 square sine 2 alpha by G. If we multiply this by B and this by B, we get B into C minus AB is equal to v0 square sine 2 alpha by G into B. In the same way, C plus B is equal to v0 square sine 2 beta by G. Multiply this by A. We have to multiply the second expression by A. We get this as AC plus AB is equal to v0 square sine 2 beta divided by G into A. If we add these two, this one and this one, we get this AB will cancel out. We get BC plus AC is equal to v0 square by G into B sine 2 alpha plus A sine 2 beta. We also know, from here we can say B plus A into C. We know the value of C here from here. We know C is also equal to v0 square sine 2 theta by G. So I will substitute the value of C here, that is V naught square sine 2 theta by G, that is equal to V naught square by G into B sine 2 alpha plus A sine 2 beta. So this V naught square by G will cancel out. We get sine 2 theta is equal to B sine 2 alpha plus A sine 2 beta whole divided by A plus B. This is the angle of projection. A particle is thrown over a triangle from one end of the base and after grazing the vertex falls on the other end of the base. If alpha be the base angle, this angle is alpha, this angle is beta. This particle is projected with some at an angle theta. Let the speed of projection be v naught. This projectile just clear the apex, the highest point of this triangle. Let this distance be y. Let this be x1. Let this be x2. We have to prove that tan theta is equal to tan alpha plus tan beta. Alpha and beta are the base angle of this triangle. Theta is the angle of projection of this projectile. So let this time be t1 when the particle is here, and after t1 it takes time t2 to reach this ground. So we can say y is equal to v naught sine theta into t1 minus 1 by 2 g into t1 square. Also we can say x1 is equal to v naught cos theta into t1. We can say y is equal to x1 tan alpha. So from here we can say y is equal to x1 tan alpha. So from these two expression I can say y is equal to x1 means v naught cos theta into tan alpha into t1. This is y. I will substitute the value of y here, then I get v naught cos theta tan alpha into t1 must be equal to v naught sin theta t1 minus half g into t1 square. So this t1 will cancel out. Our final expression becomes v naught cos theta tan alpha is equal to v naught sin theta minus g into t1 by 2. Now similarly, if we project the particle from here with same speed v naught at the same angle theta, so this particle will again strike the same point, and this in this situation we can say y and x2 are related as y is equal to v naught sin theta into t2 minus 1 by 2 g into t2 square. Similarly, x2 is equal to v naught cos theta into t2 and y is equal to x2 tan beta. So from these three expression we get v naught cos theta into tan beta is equal to v naught sin theta minus 1 by 2 g into t2. From these three expression we get this equation. This is equation first, this is equation second. If we add these two, we get v naught cos theta into tan alpha plus tan beta is equal to 2 v naught 2 v naught sin theta minus g by 2 into t1 plus t2. And we know T1 plus T2 is equal to time of flight T, or we can say V naught cos theta into tan alpha plus tan beta, that is equal to 2 V naught sin theta minus g by 2 multiplied by time of flight. We know time of flight is 2 V naught sin theta by g. So this g will cancel out, this 2 will vanish. From this expression we can say V naught cos theta into tan alpha plus tan beta, that is equal to V naught sin theta. This V naught will cancel out. We get tan theta is equal to tan alpha plus tan beta. This is the final proof. A batsman hit a ball at a height of 1.22 meter of the ground. This batsman hits the ball from here. So as the ball leaves the angle at 45 degree, this angle is 45 degree. A 7.31 meter high wall is situated at distance 97.53 from the position of the batsman. This is a wall which is situated at distance of 97.53 meter away from this batsman. The height of this ball is h, and h is equal to 7.31 meter. Now if the range of this ball is 106.68 meter, then we have to calculate whether this ball will clear this wall or not. So range, this distance is range. When the particle is projected from here, when it is at the same height from the ground as it was projected, this distance is called range, and this range is 106. So we can say R is equal to V naught square sine 2 theta by g. Angle of projection is 45 degrees, so I will substitute here 45 degree. Then I get V naught square. V naught square is range into g divided by sine 2 theta, and we know sine 2 theta is 90 degrees, sine 90 is 1. So V naught is R into g. V naught square is root over V naught is root over Rg. This is our first expression. Now from equation of trajectory, this is our origin. We know equation of trajectory y is equal to x tan theta minus gx square by 2 V naught square cos square theta. So theta here is 45 degrees, so I will substitute here y is equal to x tan 45. Tan 45 is 1, so I will substitute here 1 minus gx square by 2 V naught square. V naught square we know it is Rg, so I will substitute here Rg into cos 45. We know cos 45 degree is 1 by root 2, so square of that is 1 by 2. So we get equation of trajectory as y is equal to x minus gx square by r into g. So this gg will vanish. If we substitute x is equal to 97.5, when the particle is at distance 97.5, we can very easily calculate y. So y, if we substitute x is equal to 97.53, we get y as 8.53. If we substitute here x as 97.53, we get y as 8.53. So similarly, since this particle, this ball is at height of 8.35 when it is at distance of 97.53, so the total height of the ball above the ground is 8.35, this distance 8.35 plus this height 1.22, so it comes out to be 9.577, which is obviously more than 7.31, so the ball will clear the wall. A particle is projected with speed v, speed u, at an angle theta to the horizontal. After time t, this is the particle which is projected from here. Let this be our origin. This is our x-axis, this is our y-axis. So the particle is projected with speed v. Let the angle be theta. So after time t, let the particle is here. At this instant, the question says the magnitude of instantaneous velocity. We know instantaneous velocity is Vx I cap plus Vy j cap. As we know, V is equal to Vx means V cos theta I cap, because the velocity along x axis will remain same, and Vy is V sin theta minus gt j cap. The magnitude of instantaneous velocity is root over V cos theta square plus V sin theta minus gt whole square. This is our first expression. Now the average velocity. Average velocity we know, this is our x, this is our y. So this is the displacement. So average velocity magnitude is root over x square plus y square divided by time. So we can say magnitude of average velocity is equal to root over x means x square plus y square divided by t, which is equal to root over x means v naught cos theta into t whole square, whereas y means v naught sin theta into t minus 1 by 2 g into t whole square divided by t. So V average, question says V magnitude of this instantaneous velocity and magnitude of average velocity both are equal, means this term and this terms are equal, or we can say root over V naught cos theta whole square plus V naught sin theta minus gt whole square, this is the magnitude of instantaneous velocity, is equal to root over v naught cos theta into t whole square plus v naught sin theta into t minus half gt square whole square divided by t square. So this t will cancel out. We get v naught cos theta whole square plus v naught sin theta minus gt whole square is equal to v naught cos theta whole square plus v naught sin theta minus gt by 2 whole square. So from here v naught square, this term will vanish. We get v naught square sin square theta plus 2ab minus 2 v naught sin theta into gt plus g square t square is equal to v naught square sin square theta minus 2 v naught sin theta g into t by 2 plus g square t square by 4. So this term again will cancel out. We get this 2 will cancel out. We get v naught sin theta into gt must be equal to 3 by 4 g square t square. So again this t will cancel out. This g will cancel out. We get t is equal to 4 v naught sin theta divided by 3g. This is the time when the magnitude of instantaneous velocity and magnitude of average velocity is same. A cannon fired two cells successively in the same plane with speed u. The first cell at an angle alpha to the horizontal and the second at an angle beta to the horizontal. If the two cells collide with each other on their flights, obtain an expression for the time interval between the firing of the cell. Now suppose the two cells are fired here like this and like this. If the two cells collide, this is second cell, this is first cell. If these two cells collide in air, then we can say let the time of this be t1, the time for this is t2. So we can say t1 minus t2 is the time interval of firing, that is t. So if these two collide in air, we can say x1, x is equal to u cos alpha into t, and for the second, x is equal to u cos beta into t2. This is the first expression. The x coordinate for both will remain same. And similarly, this y is also same. So I can say y is equal to u sin alpha into t1 minus half g into t1 square must be equal to u sin beta into t2 minus half g into t2 square. This is second expression. We also know t1 minus t2, that is equal to t. This is our third expression. From first and third, we get t1 is equal to u cos beta into t2 divided by u cos alpha, and t1 minus t2 is equal to t, which says that t1 is equal to t cos beta divided by cos beta minus cos alpha, and t2 is equal to t cos alpha divided by cos beta minus cos alpha. So we know the value of t1 and t2. Now we will substitute the value of t1 and t2 in this expression. U sin alpha into t1 minus half g t1 square, that is u u sin alpha into t1 minus half g sin alpha t1 half g t1 square is equal to u sin beta t2 minus half g t2 square. So it becomes u sin alpha into t1. T1 we know t1 is t cos beta divided by cos beta minus cos alpha minus half g into t1 square means t cos alpha divided by cos beta minus cos alpha whole square, that is equal to u sin beta into t2. We know t2 is equal to t cos, this is cos beta, t cos alpha divided by cos beta minus cos alpha minus half g t2 square means t cos alpha divided by cos beta minus cos alpha whole square. After solving this, we get t, that is equal to 2u by g into sin alpha minus beta by 2 whole divided by cos alpha plus beta by